Hi, alright. So in the previous exercise, we did simple OLS regression in Excel and Python. For this exercise, we are gonna do Chow-break test. Same thing using Excel and Python. So what is Chow-break test? So Chow-break test is, graphically speaking, if you look at this graph, you have this one big long line, regression line, and the two shorter lines. So the Chow-break test attempt to break the data into two separate groups and then try to find out whether the slope of the slope of the regression line for the first group of data is the same as the slope of the regression line for the second group of data. For our purpose, we have the data from 1993 to 2010. So instead of looking at one whole data, I want to break my data into 1993 to 2004, which I call it period 1, and the period 2 become 2005 to 2010. So if you look at it, the regression line, they they might have the same beta, or they might have different beta. To say confidently about it, we have to perform the Chow-break test. To do that, we follow these steps for Chow-break test. So the first step is always to find the F statistic. F statistic is a ratio. It has the numerator and denominator. So what is a numerator? You see here, SSR all minus SSR break 1 minus SSR break 2. Then you might be asking, what is SSR all, SSR break 1, and SSR break 2? So SSR all is the sum of residual square for the regression with all the data. So in the previous exercise, we did the regressions on all the data with all the data we have, and we have these residuals, but we have to square it, and then we need to sum the residual square. And then we do the regression for the first group of data from 1993 to 2004, and then you will get the same residuals and square it and sum. Same thing for SSR break 2, 2005 to 2010. You do the regression, get the residuals, square it, and sum it. Once you have those values, you plug in into these equations, and you will get F statistic. Of course, here you also see observation, which is the number of data points. We have this observation 216, and the number of variables. So you have two number of variables here. So you have pretty all the values that you need to find the F statistic. Once you have the F statistic, you need to determine the degree of freedom for the F distributions. So there are 2 degrees of freedom for F distributions. You have number of variables and observation minus 2 times number of variables. Again, you know the value for these things. Once you have that, you will find the p-value with the obtained F statistic and degree of freedom. And the last stage of Chow-break test is a test, it's a hypothesis testing. So you need to define your null hypothesis. Your null hypothesis is that beta 1 equal to beta 2. That means you regress the regressions for the period from 1993 to 2004. The beta of Apple stock is the same as the beta of Apple stock from 2005 to 2010. So you will reject the null hypothesis if p is less than 0.05, otherwise accept the null hypothesis. So we will follow this step. We will follow these things we will follow this step and do the Chow-break test in Excel and Python. As usual, I will begin with the Excel first. So from here, you know that you need 3 regressions. The first one we already done. So I now move on to the second regressions. Let's go to data and choose regressions, and I need to delete this. So I need the data for the first period, which is from 1993 to 2004. 2004. So remember the rows E2 to E145, the X range 2004 1 4. I don't like doing this in Excel. You have to be very careful. And I don't tick the labels because I didn't choose the labels in here. I need to specify the range where I want to display my output. So I say R1. Oops. I need the residuals. Okay, done. This is the regression for 1993 to 2004. So I need one more regressions. So I click regressions, and everything else is the same. But now your data come from the second group, which is from 2005. 2005 is here to 2010. Oops, my mistake. And here 2005 begins from here all the way down, and come to AB. I need the residuals and click OK. Great. But this is not the end yet. You have to find the residual square. So I need the square of all these. I'm going to residuals J25 square. Populate all. Come here. Oops. This will be T25 square here. And this is really annoying. AD 25 square. But what you need is the sum of the residual square. So I need to sum all these. The sum of tab from here all the way down, and you get this. You will need this value to calculate F statistic. So I want to highlight that. Let's say I highlight with this one. Yep. Come here. Sum of all these cells, and then again highlight this one, and sum here down to here. Highlight this one. And with that, you can carry on. You can carry on with your F statistic value. To find that, you also need observation and number of variables. I know my observation to be 216. I just put like variable here, and I see 2. I will need these 2 values, so I highlight that one, and now I use the formula, which is this minus this minus this divided by number of variables, which I know it to be I just 2 easier, and divided by V25 plus AF25, and divided by 216 minus 2 times variables, which is 2004. Close the bracket. This is my F statistic. And you also have to determine the degrees of freedom. So degree of freedom is the number of variables, which is 2, and observation minus 2 times variables, so I get 212. With that, you can find p-value now. P-value is equal to f dot distribute. I need this one because I'm finding the area under the curve. I say f statistic over 2, 212, and this is my p-value to be 0.36. If you look at it, my p-value is not less than 0.05, so I don't reject the null hypothesis. So I accept that beta 1 is the same as beta 2. So the beta of the apple from 1993 to 2004 is the same as the beta of apple from 2005 to 2010. Cool. Now we want to do that in Python. Again, I need to import libraries. So to find these like f statistic p-value in Python, I will need to import scipy stats ss. Sorry, scipy dot status ss. Cool. Now I want to I need to define the dependent variable and explanatory variable for the two periods. I copy here. I say I dependent variable 1, 1, 1, 1. So what does it mean? Let me make it clear. So I say 1 means first period. 1 means the first period, 1993 to 2004. And 2 means the second period, 2005 to 2010. So, but this time, if I do this one, I am getting the values, all the values of apple return. The apple return, all the value from apple return column. But I don't want that because this is 1. So I only want it from 1993 to 2004. So how do I do that? In Excel, you will click and drag until you and then you stop at 2000 end of the 2004, which is quite inconvenient to me, but it is easier in Python. So in Python, I can use this function. It's called log, and I just have to specify the year. So I say 1993 to 01 all the way to 2004, the last month, and I say that's it. And then I copy the same here. So df.log 1993 to 2004 and rf. Cool. So for explanatory variable, I have to do the same. So instead of this, I copy here. And now will be not apple return, but the market return. And IF remain the same. So constant. And market just return 1. So I can just copy this chunk of lines and Control V. I change all 1 to 2. And 2 means 2005 to 2010. So I just have to come here, change 1993 to 2005, 2004 to 2010, 1993 to 2005, and 2010. So let me copy this one. Control C. Ctrl V, change Apple return to market return. Nice. I need to put this one here and here. Okay, that was my mistake. Good. Awesome. Enter. Oops, invalid syntax. Dependent variable 1. What is the mistake? 2004-12. Apple return. Oh no. Yep. Cool. And shift enter. Gone. Nice. So now you can do the regression. So to do the regression, I also just copy from the previous exercise. I call it linear regression 1, dependent variable 1, explanatory variable 1, linear regression 1. So you see, my R square, adjusted R square is 0.145, and in Excel 2, you find the adjusted R square is 0.145. You got it right. So I copy again, Ctrl C and Ctrl V, change 1, 2, good. And your adjusted R squared is 0.347, and similarly you will find adjusted R squared is 0.347. So now you have done all 3 regressions in Python, your third regression, second regressions, and first regression here on all the data. Once you have that, you can find the SSR all break 1 and break 2. So in the Python, you don't have to come here, square each cells, and then you just have to sum. In Python, it's easy. You can just call the attributes from the linear regression. So I say SSR all, SSR1, SSR2. So what does SSR mean? SSR is the sum of square residuals. So once you call the attributes SSR from the linear regression, you get the SSR value right away. You don't have to square all the cells and sum it. So I say linear regression.ssr, linear regression.ssr1, linear regression1.ssr, and linear regressions 2.ssr. Let's check my value. Or I get 3.63, and here you get 3.632. If I change to 1, I get 3.007, 3.007, I see 2, I get 0.59, I get 0.59, so same. So now I can get my F statistic. My F statistic is SSR all minus SSR 1 minus SSR 2. Let's make it more readable. Divided by the number of I forgot the equations. Number of variables. So number of variables, I know it to be 2, and divided by SSR 1 plus SSR 2, and divided by the observations. So you know that all the data points is actually 216. You can also get that value by calling NOBS norms. So anyway, I know that I have 216 observations, so I'm just say 216 minus 2 times 2, which is 4. Anyway, that gives me 212. And once I have my F statistic, my degrees of freedom is equal to the number of variables and 212. With that, I can find p-value. To find the p-value, you will need to call this library that I just imported, ss. So I say ss dot f dot sf from f statistic, comma, df1 is 2, df2 is 212, and say display my p value. What is wrong with this? ss.f.sf. Oh, let me check. Is it because I can do this? I must say p-value. Yeah. So now I have my p-value, which is 0.35689, and I saw 3.689. So they are the same. Yeah. So you have done the two break test. Oh no, because your p-value is greater than 0.05, I need to reject the null hypothesis. So what is a null hypothesis? Again, you have it here, beta 1 equal to beta 2. So that's it. That's how you do linear algebraic tests in Excel and Python. Thank you. See you again.